Hello, everyone. Thank you for tuning into this episode of the Amazing podcast. I'm Twain Taylor, editor at Amazing, and we love talking about all things cloud native, Kubernetes. And recently, we've been covering a lot of tools in the software testing space, cloud-based testing. And it's been quite interesting to see different vendors take different approaches to this challenge that organizations have. And if you like to see more of what we've talked about in the past, head over to our website, amazic.com. That's amazic.com. And you'll find all of our previous topics on whether it's testing or security or managed Kubernetes, what have you. We've got it all there. Uh, you can find us also on YouTube, Spotify, and wherever else you listen to podcasts. I'm excited today to be talking to Hassy Veldstra, who's the founder and CEO at Artillery. They're a load testing tool. It's primarily open source so far, but they do have a hosted cloud-based version as well. And Hassy is just to tell us all about Artillery, what it can do, the kind of challenges it solves, and why it deserves your attention. So really excited to meet Hassy and hear all about what he and his team are building. Hassy, welcome. It's great to have you with us.
Well, thank you. Great to be here.
Right. Hassy, as we get started, I'd love to get to know a bit about you, your background and tech, what you've done before starting Artillery, and just the point that led you to create Artillery.
Yeah, so hi everybody. I'm Hassy. I live in Ireland. My background is I'm a software engineer. That's when I started. Worked on all sorts of systems, mostly kind of web-based or web adjacent stuff, web application backends, all sorts of APIs and services. And I've always been interested in performance and reliability. And I found myself over the years kind of shifting more and more towards the platform and infrastructure and reliability engineering side of things. I was on a couple of platform engineering teams. I was on a couple of SRE teams. So that's kind of where my professional interests lie. And I'm also the original author of the open source project that Artillery is based on. And I started working on that back in 2015. So we're actually coming up to 10 years of the project.
Wow, such a
And
long.
I know, yeah, when I say it, it actually doesn't sound real. Um, but yeah, the way that started is I was working on a team that was building this new WebSocket real-time based service. And we really had to load test it because we were expecting large traffic spikes when we went to production. So I looked around to find a load testing tool that would let me load test WebSockets, and I didn't find anything. There was just, nothing that existed at the time. So what I ended up doing is I wrote some Node.js code to do the load testing that we needed to do. And then I put it up on GitHub at some point, and it just kind of, took off from there. So that was back in 2015. And, for the next 6 years or so, I just worked on Artillery as a side project. So it was just evenings and weekends, a community formed around the project, which was really cool to see. People started contributing patches and, improvements and new features and things like that. Loads of very interesting companies started using the project. And kind of at one point, I realized that Artillery could be so much bigger than, just an open source project, and that I could actually try to build something that could potentially be used by every development team on the planet. What I was thinking at the time, I think it's even more true today. Performance and reliability is only going to become more and more important. But to build something, big, something that could be used by a lot of people, I had to focus on it full time. So that's what I did. I left my job and I applied to Y Combinator. So that was in 2021. Y Combinator, for those who haven't heard of it, is a startup accelerator based in San Francisco. They fund a bunch of startups in two batches every year. So I did YC in summer 2021. We then raised a seed round, and we've been building the best load testing tool on the planet ever since.
Awesome. Wow. That's quite a story. Was it a big leap for you going from your job to uh, applying to Y Combinator? Did you see it as a risk, or was it a very natural thing and you knew this was going to be big?
Well, I just had to try. I think that's what it was. I could see that there was a kernel of something potentially very, very big that we could make performance and reliability testing as easy to do and as popular as unit testing or integration testing.
Mhm.
So just had to take a leap. It wasn't really based on, any more consideration than that. I suppose,
Mhm.
in our industry, we're quite lucky, or at least that was the case in 2021. Things have changed a little bit. Um,
Mhm.
there's a lot of opportunities. So taking a risk isn't always as risky as, it might seem. And
Mhm.
then, getting into YC and getting funded by YC just made it so much, so much easier to continue down on that path. But yeah, it's being a founder, even though, I still write code every day, most of my days, that's what I do. It is very different to being, an IC, an engineer, but it's a lot of fun.
Mhm. Neat. Wow. You mentioned performance testing is not as popular as unit testing and integration testing. Could you tell us the reason for this or the reasons for it?
Yeah, so there's a few different reasons. I'll maybe take a step back here and actually talk about what it is that we do. So the way we describe artillery today is that it's a complete load testing platform. So it gives you everything that you need to go from absolute zero, no performance testing of any kind, to doing production grade load testing in a matter of weeks, as opposed to, months, or years in some cases. And the idea behind load testing as a whole is pretty simple, right? You have an application. The application is probably, quite large. It's made up on several different components. You probably have multiple developer teams working on this application and releasing updates continuously, whether it's full continuous deployment or some, other version of it. So when you have all of these updates and deployments going into production, how do you make sure that your application can handle traffic spikes? How do you make sure that performance doesn't degrade over time, that you don't introduce performance regressions? So that's where load testing comes in. And at its core, what you do when you load test is you describe how real users use your application, and then you use a load testing tool to create a lot of those users. It could be thousands, tens of thousands, could be millions if you're operating at really large scale. You do that, and then you see what happens. You look at what breaks, you look at maybe you know, things like, did our application servers autoscale as we expected? Did our database autoscale as we expected? You might say, oh, look, this service here is taking up too much CPU and we can autoscale it, but it's going to be really expensive. Let's optimize that. That's what you do when you load test. Um, the thing is that and that's part of the reason for why a lot of teams kind of don't really load test, or they leave it until the last moment, is that the tooling that exists today is often really, really clunky to use, and it's not cloud native. It's not built for the way that developers work today. Um, it tends to be really over optimized for a particular persona or a particular type of workload, which means that only, a specific team can do load testing. And it's not optimized for, to make performance testing into kind of a team sport where every developer team, where every QA team, every SRE team can do load testing.
Mhm. Mhm. All right, all right. Really interesting there. Um, one thing that I found interesting in what you mentioned is that with new releases coming in, there's one issue of making sure it doesn't break stuff at scale, especially. But also interestingly, what you mentioned that over time that performance shouldn't degrade. And I feel like that is because when a lot of people think of load testing and performance testing, they think of reliability as an avoid downtime,
Yeah.
and which is very essential, and it's like It's like the meat and potatoes kinds, you need that. But then, um, you know, but thinking beyond that, how do you, improve on performance? I think that is more the, uh, like beyond the basics kind of thing for load testing and performance testing, right? Would you agree?
I would agree, absolutely. I think the trend that, it's been true probably for the last, I don't know, 20 years. Um, Production systems get more and more complex, every single year. And with that complexity comes risk, and with that complexity comes emergent behavior, So even if we take, let's say, the microservice-based approach, right, which is kind of the go-to standard these days, and it works really well from kind of organizational or business perspective. It's the approach that lets many different developer teams contribute to this single distributed application. Um, but one of the downsides of that is because you have that many services, uh, the number of possible interactions between them absolutely explodes. And there's a lot of emergent behaviors that arise through all of those interactions. And you can't really logically reason your way through them. Let's say if I'm working on a single service and I have, some code that I'm looking through, very often I can just, read the code kind of top to bottom and sort of, figure out what it's going to do when it's running. When you have multiple services, you can't do that, because it's not just to do with even the services themselves anymore. Um, all sorts of other considerations come into play, like the underlying infrastructure that the system runs on, or any third-party dependencies that you talk to. So when you have a system that is that complex with potentially that many emergent properties, the only way really to see what it's going to do in production is to test it in a production-like way or in a production-like environment. And load testing is one of the best tools to do that, because you put a stress on the system and it shows you immediately where the bottlenecks are, where the potential deficiencies are, or what is most likely to break. Um, it's kind of like, an analogy that I often use is if you're building a new type of car, right? It's comprised of many different parts. You've got the wheels, you've got the steering wheel, you've got the engine, you've got, the body of the car, and you can test each one of those things individually. That would be like the equivalent of your unit test or integration tests. And then you can put the car together and you can maybe, drive it up and down the street a few times. That would be your end-to-end test, I guess. Um, and you can say, okay, I can actually get into this car, start the engine, I can drive up and down the street, but that's not enough, right? What you would also do is you would put it on a racetrack, or you would put it into the desert or some other realistic conditions and really, really try to break it and try to stress it to figure out like the things that you haven't even thought of, or to see interactions between components that you couldn't even predicted before you did that. So load testing is that exact same thing, but for complex software systems.
Got it, got it. To drive the point home, I was wondering if you could share some examples that you've spotted in the news in recent months of where some incident, downtime, or something that happened that was caused a big mess, but it could have been avoided if the organization had actually had a good strategy for load and performance testing.
Yeah, so it's an interesting one because every single week there are outages of pretty big services, or parts of very big services. Um, if I think about it, the one it's not that recent. I think it was maybe it was over a year ago, I think. But Ticketmaster had a massive
Mhm.
outage when Taylor Swift tour concert went on sale. It was bad enough that the CEO of Ticketmaster was brought in for questioning in the Congress in the US. It made the
Wow.
headlines. And this is not to say that Ticketmaster do not have a load testing program. I'm sure that they do, and I'm sure that they spend a lot of resources on it. It's what they do, right? They sell tickets. But I think that example is really great at illustrating just how complex stuff is and how much a spike in traffic can really, even stress your own understanding of the system. So Ticketmaster have probably some of the best people in performance testing and some of the best internal tools for it. And still, they went down under a large traffic spike. So, one way of looking at it is to maybe, what what hope is there for the rest of us? We need better tools as an industry to performance test and reliability test everything that we do.
Yeah, yeah. Wow, really interesting example there. But one of the things you mentioned earlier is, in your example about driving and testing a car, is that the real test is when you take it out into the real world or on a racetrack or somewhere or in the desert and you try to break it. So you're basically trying to, with applications, you need a production-like environment, or in other words, probably simulation. But yeah, how do you simulate real-world scenarios accurately for applications? How do you simulate Swifties for Ticketmaster?
It's a bit of an art, and it's really application dependent and application specific. So usually what you would have is people, and this could be a developer, this could be a QA engineer, this could be even someone on an SRE team. They would look at historic patterns of traffic and user sessions, and they would extract the most common ones, or what they think are maybe the most risky ones from a performance perspective, and they would then encode that as scenarios for a load testing tool, and then start the simulation with a lot of those virtual users. It really, there's several different ways of doing it. So this way that I just described is one of them. Another way to do it is to use a technique called a traffic replay, which is also quite a popular approach. You had, I think, someone else on the podcast talking about that. Um, and that can work really well, but it doesn't work for every system. Where traffic replay usually works really well is if you have a system where most of the requests are idempotent, meaning that sending the same request over and over again returns, the same response from the service, and it usually means that you cannot, replay any sort of destructive operations or any operations that modify state. So it tends to work really well for websites like classifieds websites or news websites where there's very little personalization or just not a lot of state. But otherwise, someone who is actually modeling real user sessions in some way.
All right, all right, got it.
And then the other aspect of this is where you're actually testing your application. And these days, most teams, definitely most teams that we see, they will have some sort of a staging environment or a
Mm-hmm.
performance testing environment where a replica of the application is deployed, and they try to match what the infrastructure setup looks like as well as close as possible to production. But of course, you can never replicate production completely. And a
Mm-hmm.
lot of the time, there are subtle even differences that actually can lead to very different performance profiles. So something that we're starting to see more and more of, and it's actually something that we officially try to recommend to as many teams that we work with, is to do load testing in production, meaning that you throw synthetic load with artillery at your production system. And it's a it's an interesting one because it tends to elicit very strong reactions, either very strong negative reactions or very strong positive reactions. Um, but what we found is it's actually a lot more often than not, or than you might think, it's very possible to do load testing in production and do it very, very safely. And the benefit of doing it in production is that, you know, you get much stronger guarantees that the behavior that you're seeing from a load test is actually going to translate into the real world because you are testing the production system.
Wow, okay. Yeah, that is quite a thing because, yeah, I think a lot of vendors do take the approach of creating a production-like environment that's very closely simulating production. But you're saying, no, we're going a step further. We're going to load test in production. That's quite groundbreaking.
It's what we find is it does require quite a bit more work because you need to set up your load tests in a certain way. You need to make sure that, you can control the traffic that's being sent. You can stop it at any time. Um, there's usually quite a bit of stakeholder management involved in this,
Mhm.
because
Mhm.
let's say if you mentioned to product that you're going to be load testing production, they're going to have opinions. So, usually teams that want to start doing it, there is a roadmap from, anywhere between like 3 to sometimes 12 months, depending on the size of the company and the complexity, um, where they get to the point where they're load testing in production. But every single time, once a team has run a load test in production, it's like a, light bulb goes off. It's like a almost, this this switch just toggles and people go, oh wow, like we can actually see now how much more confidence this has given us because we're load testing the actual thing and not some replica of it. It just takes
Mhm.
you a lot further on that, um, like continuum of confidence, which is what we're trying to do with testing, right? Any kind of testing. We're trying to get as
Mhm.
far to complete confidence. It's not possible, of course, but that's what we're trying to do. Um, yeah, like in practical terms, there are a few things that you need to do. You need to instrument your application. Sometimes specifically for load testing and production, you need to structure your load test in a certain way. But yeah, it's a lot more doable than a lot of people realize, and the benefits are immense. So we recommend it to a lot of teams that we work with.
The question that comes to my mind as I'm listening to you is one is how do you isolate the tests in production so that they don't affect the production app itself that's running? And two is how do you create this synthetic load that you were talking about? Could you give us some more details about that?
Yeah. So with load testing and production, that thing you said about separating traffic, like that's absolutely critical. So what you would usually do is you would use a staged approach. So you don't need to load test the entire application at once, for example. Your first step can be to add some extra synthetic load in production, but only to read operations or read portions of your app. So you're not actually modifying the database or any state in any kind. Um, the way that you would distinguish synthetic traffic is, let's say if you're testing a HTTP-based system, very common thing to do is to inject a special header that tells you that the traffic is coming from a load test. And then based on that header, you can do, different things at different layers of your application. So one example is um, you can look at the header and then maybe not count the traffic from your load tests in your product analytics, right? So that would be one layer of the system. Another layer of the system is if, say, you have, um, let's say you're testing an e-commerce website and you want to synthetically test the entire user flow, when you get to the actual checkout, if you see that it's coming from a load test, you would just like no opt that operation. So you can go all the way, but not actually try to charge a card or maybe send a confirmation email. Um, and that ability to distinguish that traffic comes in, yeah, very useful in a bunch of different places. And that kind of goes back to when I said how you may need to extend or instrument your application to be low test in production, but it's not different to adding instrumentation, say, for observability or logging or security, which are things that we do as developers all the time. So it's just another little thing that you need to make your application aware of.
All right, got it. Wow. So we've covered quite a bit actually already, talking about different perspectives around load testing and performance testing and the different approaches, and even debunking some quite a few myths actually along the way. Really interesting.
I could talk all day.
Yeah, yeah. Sounds really, like it's quite a unique perspective that you're bringing around to the conversation around load testing and performance testing. But tell us about the approach artillery takes. What's unique about it? Uh, yeah, what's different?
Yeah, so funny thing, right? We're in 2024, second half of it now, and I think it would be a very reasonable thing to say that we're in a cloud native world, right? At this point in time. On-prem is not going away, it's not going anywhere, but cloud is the default now, right? But when you look at load testing as a product category as a whole, it's actually still very much kind of stuck in that pre-cloud native world. And if you look at popular load testing tools, open source and commercial, there's loads of them out there. Artillery really is the only one that doesn't pretend like the cloud doesn't exist. And what I mean by that exactly is, again, if we like step back a little bit, right? If you're going to, as a team or as an entire organization, if you're going to do load testing, and if you're going to do it continuously, and if you're going to do it at scale, then you have to test from the cloud. There's just, no other option. Otherwise, you have to keep a lot of spare capacity just for load testing. You have to manage it. That's what we did in the 90s, I guess, in the early noughties, but we don't need to do that anymore, thankfully, right? There's so much elastic compute in the cloud. So that kind of breaks down into three things, right, for production grade load testing. So one is scale. You want to be able to generate as many virtual users as you need, whether it's, tens of thousands or millions. Your load tests they absolutely have to be distributed. Like you don't want to run, from one machine or even like a small number of machines. You want many of them. You want multiple IPs. It affects even, the kind of load profile that you might generate needing to do that. And then the third thing is that you need to load test continuously. So you're not load testing, once or twice a year as we used to do, but you're doing it on a regular cadence of some sort. It might be, every 2 weeks, every week. Some teams do it every day. Some teams do it on every release. So multiple times a day when they release to production, but there's some sort of a cadence. And cloud is perfect for that, right? There's a lot of compute on demand. You can do load testing, which is distributed geographically, and you can kind of scale it out infinitely, right, to whatever you need. And like that's what I mean. If you take other load testing tools, so I'll maybe just take one as an example, which is JMeter, which is the most popular one by far, and most people have probably at least heard of it. It's a great tool, but it doesn't have a distributed load testing story built into it. So if you want to run a distributed large-scale load test, you're left with creating and managing and setting up infrastructure to do that. So that's one aspect of it. And the other aspect of it is that your developer experience doing that is not going to be great. You're going to need probably, a dedicated person, maybe even more than one, to do that for you. So this is where Artillery is different from everything else. We are cloud native just out of the box and by default, which means that kind of to translate it to the experience of an individual developer, I can install Artillery today, npm install or brew install, whatever you might be using, whichever package manager. I can write a test script and I can run it on my Mac to, make sure that everything works. And then once I've done that with Artillery, I can just add an extra command line flag. And all of a sudden, that same load testing script is now running from AWS, and it's running from 100 serverless containers in any region that AWS supports. And me as a developer, I don't need to care how that infrastructure is created, who manages it. It's completely on demand, it's completely serverless, and Artillery just takes care of it for me. So we've completely abstracted away that notion of compute infrastructure and where your load test runs from. You can just run a load test and you can scale that horizontally as much as you need to. And that really changes like the entire approach that teams take to load testing. We see it from experience. Because it becomes so easy to do, we're seeing teams doing regular load testing that would never have done it, previously. Like we're talking about maybe QA teams that have never, logged into AWS, have never, run kubectl or anything like that, because they don't need to care about that stuff anymore. They just want to run a load test so they can do that.
It seems like organizations are still transitioning to the cloud, and especially testing teams, there are quite a few of them that, they haven't set foot in the cloud yet. And, I'm sure that many listening, watching this also are kind of in that situation where testing in the cloud is still not a thing in their organization. Although they've heard about it and they know it's better, there's hurdles, there's obstacles, there's stakeholders that they need to convince. You're talking to customers like that, what have you found as some of the best ways to break through and, get testing done in the cloud, get started, get some momentum in this direction?
Yeah, this is a really interesting subject. So it's actually, I can't remember the exact number, but Microsoft, as part of their last earnings call, I think it was, they released some numbers on what percentage of the world's workloads are still on-prem, and it's a crazy number. Like I can't remember what it is exactly, but it's more than half. So I did say just a few minutes earlier that we're in a cloud native world. Cloud is the default, but there's a lot of stuff out there that still runs in data centers and it still runs on-prem. But what we're seeing, in our small slice of the world, and it's something that that Microsoft report also talked about, is more and more of those workloads are being lifted and shifted to the cloud now. And usually what happens is that's what kind of pulls up the testing activity into cloud as well. Because a lot of the time, if your stuff runs on-prem, you might not even have the ability within your, organization to use the public cloud to even test it. So we see a lot of that. What tends to happen is an organization like, say, financial service institution of some sort, they decide to, first of all, go to cloud by default for all of their new applications. That's how it tends to happen. Um, you know, these tend to be quite large multi-year digital transformation projects, but they'll dip their toes in with cloud to start with for new stuff. And that's when we see teams that, find and adopt artillery, like really start exploring cloud-based testing and cloud-based load testing specifically with us. And they would use it to performance test their new stuff. And there's a large kind of educational component to it, right? Because if you're moving from on-prem to cloud, everything kind of changes, right? Not just the fact that you can now provision a server from a web console, but the way that you architect things is completely different. Performance and reliability profiles of everything become completely different. So it takes a while to catch up with all of the differences between the two worlds. So that's usually step one. Step two, and that's what also is really interesting a lot of the time, is companies that start moving legacy workloads into cloud. Performance is usually one of the top concerns. And it is for those reasons of, different architectures and different expectations. But also just, purely from, say, customer experience or product perspective, if you're going to completely migrate the architecture of something, you need to absolutely make sure that performance at least doesn't degrade. Most of the time it actually improves. But you have to make sure that the new thing is as performant as the old one. And again, what we see with load testing with artillery is that teams adopt load testing as kind of a guardrail around that. So they look at the performance of the legacy system. They usually encode, a set of requirements as SLOs, and then they use continuous load testing as the new system is being developed to make sure that those SLOs are never exceeded.
Mhm, mhm. All right. So coming to the end of our conversation, but lastly, I want to touch on just where you see this space headed and even artillery itself, what's on the horizon for it. Does AI play a role at all, or is something else more exciting that's happening in the space of load testing? Give us a hint of what's coming.
So um, I think AI is really, really interesting. So for load testing specifically, we are looking at AI. We've got a couple of things in the works, but we haven't seen a lot of pull from our customers or users for features that would specifically be enhanced by AI, which is quite interesting. If I look at the workflows, kind of day-to-day workflows of users of Artillery, where they use AI and where AI really helps is co-pilots. So for example, if you go to ChatGPT or if you go to Claude today, you can ask it to write an artillery load test for you, and it will do it for you. It knows artillery, it knows how it works, it knows all the features. It's actually really incredible. I was using it myself the other day.
Mhm.
Um, So that's like, in the space of like load testing, that's where AI is most useful at the moment in day-to-day workflows.
Mhm.
Where I think AI is moving us in a longer kind of on a slightly longer timescale is that with generative AI and with things like Claude or ChatGPT or just LLMs in general, being able to write more and more code, operating software is going to become a lot more important and a lot more difficult than writing software. On a long enough time scale, there's an argument that the cost of writing code is going to come down to almost zero. But the hard part is going to remain um, how you actually operate all of that code and how you operate it in production and how you make sure that it's performant and scalable. And from that perspective, I think what we're doing at Artillery is, even more important than when we started. There's just going to be a lot more lines of code that are kind of even less understood by an individual developers doing really important things out there in the real world and like running our lives. Everything runs on software today. Um,
Wow. Really interesting that response because it tells us, what's possible today with AI that, could just make operations a lot more easier for those who are transitioning into something like continuous load testing, which you mentioned, or testing in the cloud at scale. AI can definitely help today itself, but you also give us a really good idea of uh, 5 years down the line, perhaps 10 years, that really interesting concept of how writing and creating apps are going to be very cheap, but running them is going to be the challenge. And so
yeah,
that's quite,
look, I'm a
yeah.
I'm a developer. I love writing code, right? But I think it's inevitable. We're going to be actually writing less and less code over time. I
Mhm,
use LLMs just day to day, and they're great. But
mhm,
um, personally, and I suppose it's a bet of sorts. I don't think that LLMs and AI are going to make that much difference, at least kind of on a short time scale. Yeah, maybe the next like 3, 4, 5 years in helping us actually run that code in
mhm,
production because there's just too much complexity and too much emergent complexity there.
mhm, mhm. Yeah, yeah, makes sense. Wow. Yeah, before you uh, go, Hassy, I was just wanting to ask you one question to get to know you a bit. Tell us what would be your alternate career path if not for your job in tech?
Um, it's a tricky one, right? I think if I could choose anything kind of with that regard for, my natural talents maybe or aptitude, if I could just wave a magic wand and magically be really good at something else, I'd probably say pilot. I've just always
Okay.
been fascinated by planes and, flying and
Mhm.
just, yeah, everything to do with aviation. I think that would be a cool job, very difficult job from what I know, but probably
Mhm.
be fun. But yeah, if not for that, I don't know. I really
Mhm.
don't know. It'd be some sort of a thing where I can optimize the performance of something.
Yeah. Do you have a favorite airplane that you've followed or you've read a lot about its history or its creation, any particular model of an aircraft?
Not any particular models, I suppose, no, but I love smaller planes,
Mhm.
something that I could maybe learn to fly one day, but no, nothing specific.
All right. Cool. Yeah, thanks for joining us today, Hassie. It was great
It was
talking to
fun.
you about load testing and artillery. Just a lot of great ideas that you shared. Yeah, it was a pleasure to have you join us. Do come again when something big happens at artillery that you want to talk about.
Sure. Yeah, thank you. I had fun.
All right, and thanks to all of our listeners and viewers as well for tuning in. We hope you enjoyed this conversation as much as we did, and we'll see you on the next one. Bye-bye.